Yeah, hello, ladies and gentlemen. And my name is Monglun Chai. And today I will introduce about the HD maps in Taiwan. And this is my outline. And I will separate two parts. And first part I will introduce about the Taiwan HD maps. And the second part is about the land-to localization issue. And first, let me take a short discuss about our center. According to the planning from MOI and National Cheng University, so we set up high definition map research center in Taiwan. And here shows about our purpose of center. And the topic of our center includes verification, communication, standard safety, and cooperation. And this video shows about the production cycle of HD maps. And the HD maps in Taiwan include four parts: static map, transit static map, transit dynamic map, and highly dynamic map. Reference local dynamic map concept. And there are two kinds of map method to acquire the data: the professional mobile mapping system and certified third-party sourcing. And after we collecting all the data and making and verify the item and accuracy of HD maps, this certified vector map will convert to the standard format, and then this data will upload to the cloud. And then end users can download this map for the autonomous vehicle. In order to make sure that the final result of HD map reach same level and accuracy, so we we publish the high definition map technical guidelines and standards. And this table shows about the document and publish time. And there are three kinds of HD map formats in Taiwan, includes point cloud, is last format, and vector map is shared format, and the Taiwan HD maps, open drive with extension format. And this format can also convert to the format that the company need. For example, the Autoware, the related to DMP or NDS and others. So this video shows about the recommended steps for HD maps production. After the map makers collect all the data, the certified point clouds will be made reference the Taiwan HD map operation guidelines. And then the vector map and Taiwan HD map will be made reference the Taiwan HD map standard. And finally, the HD map production test the simulator autonomous vehicle verification. And this map will be published for Surveillance Service Research Institute and autonomous vehicle. And here shows about our HD maps result in Taiwan car lab test field. And here shows about the point cloud and vector map. And this part shows about our open drive for Taiwan. And we use the VTD to simulate the car can drive smoothly or not, and also check about open drive format data. And the second part will show about the lane to semi-autonomic validation and localization algorithm.
So okay, now I'm going to share our result of the designing the linear to semi-automated validation process. So here you can see that we have produced a procedure of validating the linear 2. We have three sections. So the first one is the format validation. Second is the logic validation, and third is the 3D visual validation. And these some of the function is based on Autoware Foundation's software, and And based on this function, and we have also tried to make the validation process that is more suitable for the Taiwan HC map. So we also have the detailed and the suitable standards that we have made here and try to implement in the Autoware Foundation functions and some of the methods. So right side you can see some, this is the salon in Taiwan, and we have tried to use the Lander 2 map to do the validation. And this is some of the results that we try to execute. So you can see that in the main execution improvement by using this kind of tools that we can improve about 98% of the whole time cost and also the money cost, and also the execution speed here that in using our tools that we can about in 1 minute we can process about 5 kilogram square kilometers areas in here. And next, also we have focus on doing the localization algorithms in here. So we have developed based on the inertial navigations, and this is some of the architectures here. And we are trying to get the weighing lane levels accuracy here about 0.5 meters accuracy. And we try to work on the multi-sensor case, including the IMU, GPS, and HCMAT and LiDAR. And we aim to work in all environment here. And also we have planned to merge in Autoware universe in the future. So here's some of the results by our localization algorithm. Then we can see that in this field we have go to the urban area and indoor scenarios, and we can see the root mean square error from our algorithm here. The horizontal is about 0.5 meters, and in 3D we it's also about 0.5 meters accuracy. And next is the featureless and open sky areas. So we also can see that the accuracy in the horizontal and the 3D. We have the root mean square error about 0.3 meters. And yeah, so this is some of the results from we have developed the algorithm here. Okay, so I think this is uh, uh, the the result and our content. Thank you.